Hello everyone and welcome back to Anupam Tech Talk. In today's episode, we are going to talk about database constants. We have already discussed primary keys and foreign keys, and today we are going to take that concept one step further. A database does not just store our data, it can also help make sure that the data we store is valid. That's where constants becomes important. So today we will understand what database constants are, the most common types, and why they are important when we are building a reliable application. Let's start with simple scenario. Imagine our application allow some invalid information to reach the database. Maybe customer's name is missing. Maybe two users accidentally guessed the same unique identifier, or perhaps we receive an impossible value such as negative age. In this data is stored successfully. It can eventually create problem for our application. Bad data leads to a bad decision, which leads to bad application behavior. So we need mechanism that helps protect the integrity of our data. One of those mechanisms is database constants. A database constant is essentially a rule that the database applies to our data. It tells the database what is allowed and what is not allowed. If an application tries to insert or update the data that violates one of these rules, the database can reject that operation. This is important because it gives us an additional layer of protection. We are not relying entirely on application code to keep our data correct. The database itself becomes a guardrail of our data integrity. We have already seen the first type of constant, the primary key. A primary key uniquely identifies a record in a table. For example, customer ID can be the primary key in our customers table. The database will make sure that two records does not have the same primary key value. It also cannot be null. So a primary key is both an identifier and an important data integrity rule. In fact, you will think of a primary key as a combination of not null and unique constants together. The next constant is not null. As the name suggests, this means that a column cannot contain a null value. For example, perhaps our business requires every customer to have a name. We can define that column as not null. If an application tries to create a customer without providing a name, the database can reject that operation. This is simple constant, but it can prevent a lot of incomplete data from entering to our system. Another useful constant is unique. Unique prevents duplicate value in a column. A column, a common example is an email address. If our application requires every user to have a unique email address, we can enforce that rule at the database level. So if someone tries to insert another user with an email address that already exists in our database can reject it. Again, we are we are moving an important business rule closer to the database itself. The check constants allow us to define a condition that a value must satisfy. For example, if you are storing an age, we probably do not want a negative value. We can create a check constant that requires the age to be greater than or equal to 0. Now, if an invalid value reaches the database itself can reject it. Other examples, salary must be positive status. Status must be one of the specific set of values, or ordered order date must be before ship date. This is another example of protecting data at the database level. Another useful constant is default. A default value is automatically used when the Addis application does not provide a value. For example, when we create a new user, perhaps the default status should be active. Instead of requiring every part of our application to explicitly send the status, we can define a default value in the database. This can make our data model more consistent and reduce unnecessary application logic. Note, default technically does not reject data, it fills gap when no value is provided. And finally, let's connect this back to our previous episode, the foreign key. A foreign key helps maintain the relationship between two tables in an ordered references customer ID 101. The database can verify that the corresponding customer exists. If customer ID 999 does not exist, the database can prevent an invalid relationship from being created. This is called referential integrity. So, foreign key are not just about connecting table, they are also about protecting the correctness of those relationships. Now, here is an important engineering point. Should we rely only on database constants? Not necessarily. Our application should still validate input and provide a good user experience. But database constants provide another layer of protection. Think of it as defense in depth. The application validates the data and the database provides another level of protection before that data becomes permanent. This is This becomes particularly important when data can come from multiple application services, scripts, or integrations. This brings us to today's engineering mindset. Instead of simply asking, can my application prevent bad data? We should ask, where should this rule live? Some rules belongs to the application for user experience and immediate feedback. Some rules are important enough to enforce at the database level for data integrity and consistency. And sometimes we need both for defense in depth. Good system design means understanding where a rule should be enforced and making sure that important data cannot easily becomes inconsistent. Let's quickly summarize today's episode. A primary key gives a record a unique identity. Not null makes sure required value are provided. Unique prevents unwanted duplicates, check, allow us enforce conditions on values, default provides a fallback value, and foreign key helps protect relationship between tables. Together, these constants helps us build a database that does not just store data, but also protect the quality of that data. And that's it for today's episode. Database constants may look like small technical details, but they play a very important role in building a reliable system. The more applications and services we have interacting with our data, the more important it becomes to protect the data at the right layer. So remember, do not just store data, protect its integrity. If you found this episode helpful, please like the video, subscribe to Anupam Tech Talk, and share it with someone who might find this useful. I'll see you in the next episode we, a- as we continue exploring practical engineering concepts. Thank you for watching.